You are welcome to the lecture GNS 311, The Structure of Science, Scientific Methods and Revolution. At the end of this lecture, you should be able to define science and to identify the components of the structure of science. Also, you should be able to identify and describe the product of science, the processes of science, and the ethics of science. You should also be able to describe and discuss the functions and limitations of science. You will be able to identify and discuss the three characterizations of the 17th century and to describe the history of the two major forms of scientific methods and life histories and achievements of the major scientists of the 17th century. You will also be able to describe the organization and the roles of the major early scientific societies or academies during the scientific revolution as the forerunners of the scientific societies in the contemporary world. Structure of science. Before we get down to discussing the structures of science, it is important to see how science is defined. Science is defined in various ways by various scientists according to subject areas. However, whatever way science is described or defined, three components of its structure must reflect in the definitions. Hence, science is defined as a body of knowledge, a way of investigating, and a way of thinking in the pursuit of an understanding of nature. Now, let's take a look at the products of science. Every product of science is a matter of knowledge and has four various forms, including concepts, facts, laws, and theories. So we are going to take a look at these four forms one after the other, starting with concepts, which are meanings given to scientific symbols or labels, including words, formulas, or mechanical models. Concepts are of three types. We have the empirical, theoretical, and relational. The empirical concept is by inspection, concrete, or observable, while the theoretical are concept by definition, abstract and observable or unobservable, while the relational concept relates to two or more concepts like equal, proportional, inversely proportional, or greater. The next form of knowledge is facts, which is an event of the past recorded by people without disagreement whatsoever among observers. Future disagreements may occur though, but when that happens, then the past knowledge becomes obsolete with respect to the present one. The third aspect of knowledge is laws. Scientific laws are also called principles. They are also called rules or generalization. Scientific law is a brief statement or mathematical formula that predicts interrelationship among concepts. There are two types of laws. That includes empirical law and theoretical law. As can be seen in the diagram, the laws are the empirical, theoretical, which are also, explained one after the other. While the empirical predicts interrelationship among empirical concepts, it does not explain the prediction made. While the theoretical law predicts interrelationship amongst theoretical concepts, this one explains the prediction made. And theories as a form of knowledge is more advanced than law and combines several laws in its formulation. A theory is a system of logical reasoning that scientists carefully construct to explain the unknown based on valid assumptions about natural phenomena. All theories must take into account all known facts. So, scientists never prove theories true or false. They rather see it as whether it is adequate or inadequate to explain a phenomenon. Now let's take a look at the processes of science. Processes of science are the methods and skills that scientists employ in their various works. These are tools of accuracy, conciseness, and precision. So, various types of science processes include observing, classifying, inferring, predicting, measuring, communicating, interpreting data, and experimenting such data. What are the ethics of science? That's our next discussion. They are attributes of a scientifically literate person. These are characterizations that a scientist must have, must reflect in his behavior. These include curiosity, that is, he must be curious, he must be positive, he must have positive approach to failure, he must be open-minded, he must be objective in his study, and he must be unwilling to believe superstition. He must have respect for other scientific opinions, and also he or she must also be willing to suspend judgment until any argument is checked or proven. He must be willing to accept criticism. He must be dynamic, cooperative. He or she must be anti-authoritarian. He or she must have accuracy of observing and reporting analysis and findings. He must have morality and be universal. Next is functions of science. Amongst other things that science does, it describes and relates us with the universe to create a niche. Science satisfies our desires to know and to give intellectual satisfaction. It also enables us to predict consequences of our actions. Science provides us with the achievement of the present and future. Even with all these advantages, science also has some limitations, including the fact that it does not take decisions by itself. The laws of science are not enforceable. And at times, the predictions of science can be inaccurate. Also, science does not believe in miracles, and it takes time to explain causes of unexpected outcomes. Scientific methods and revolution. The 17th century is popular by the fact that a lot of scientific revolutions occurred during the period. It is during the period that a lot of scientific geniuses were discovered. Scientific societies also sprang up during the 17th century period. A number of scientific methods were developed during the period by Francis Bacon and René Descartes. Earlier scientists before then were only interested in discoveries and invention without much emphasis on practice. Therefore, experimental methods started influencing scientific society and communities altogether. So, as a result of this movement, Galileo Galilei was discovered or noticed as the first scientist to employ modern scientific method fully in physics and astronomy. Also in this line, Francis Bacon in 1620 published a book on philosophy and the method of scientific investigation. A formulated series of steps to account for scientific methods which forms landmark in systemization of science. Bacon again proposed systems of forming scientific organizations which was adopted for the formation of the Royal Society of London in 1660. However, in the opinion of René Descartes, he preferred mathematical reasoning and deduction to the experimentation and deduction by Bacon. Newton, on his own, succeeded in integrating the two opposing scientific methods of Bacon and Descartes. Century of geniuses. Another way by which the 17th century was marked is that many geniuses were discovered during the period. Galileo Galilei, who discovered that the moon is not a smooth shining sphere after all, and that it is only a surface of mountains and craters. He also discovered that the Jupiter has the moon revolving around it, and also that the Milky Way is made of many stars. Galilei also discovered that the sun was the center of the solar system, and that the earth is not stationary. Another genius discovered in the 17th century was Johannes Kepler, the man known for laws of planetary motion. He explained the motion of planets around the sun. He also proved that the planets orbit the sun in elliptical paths rather than circles. Kepler formulated the three laws of planetary motion, which are still used in astronomy till now, and the planning of orbit of artificial satellites. William Harvey, the proponent of circulation of blood, is another genius that was discovered in the 17th century. He discovered that the heart was not seat of emotion and source of life. He showed that the heart only pumps blood and keeps it in circulation in a closed system that is called blood vessels. Harvey is regarded as the founder of physiology. Isaac Newton is another genius that was discovered in the 17th century. He matched the scientific method of Bacon and Descartes. He discovered the laws of motion and the law of universal gravitation. Newton invented calculus, and he described the beam of light as bands of many colors, as in the rainbow. Newton also discovered the reflective telescope that is being used worldwide today. The organization of scientific societies. Another characterization of the 17th century is the organization of scientific societies. Earliest of these societies and academies were founded in Rome in 1603. Amongst them is Academia delle Scienze, which replaced Academia Secretarium Naturae, founded in Naples. It was closed down for meddling with witchcraft. And the oldest of them is the Royal Society of London, which started its formal meeting in 1660. So far, the lecture has discussed what science is. It has also spoken about the components of the structure of science. It has also described the products of science, the process of science, and its ethics. We have also discussed the functions and limitations of science. Also in the lecture, we discussed the three characterizations of the 17th century and described the history of the two major forms of scientific methods and life histories and achievements of the major scientists discovered during the 17th century period. The lecture also discussed the organization and the roles of the major early scientific societies or academies during the scientific revolution as the forerunners of the scientific societies in the contemporary world. And lastly, the lecture listed major scientific societies.